found. It's your tutor again, Mr. Sensor, and the following tutorial is a preparation under pure mathematics. Basically, our topic is logarithms. And then under this topic, our focus under discussion is introduction to basics under logarithms. To talk more, we're going to find that logarithm expressions are connected to indices. Indices in mathematics are best known as exponential expressions. Let's see what we have to do. So under logarithmic expression, we can be able to have something like 2, then raised to the power x. The first and foremost to understand is that inasmuch as this contains a power, this can be said to be a base. And then this one, which we have here, is a power or an index, but can also be said to be an exponent. So this one is an exponent. So we can be taught at times to convert this index or these exponential expressions into a logarithmic expression. Then also to add on to what we're going to discuss, we will try solving logarithmic expressions or equations in order to see how best we can be able to fully introduce the topic of logarithms. So let's see. So given an example, let's say we have 2 to the power x equals to 4. If we are taught to express such an exponential expression into a logarithmic expression, the first important thing, we're going to write our initial logarithmic word in terms of an abbreviation, log. And then the power, this base which is here, remains the base. Then the actual number that the equation was equated to becomes the main base. Then this will be equated to the power. Remember, I've said the base becomes, that is the minor base here. Then the actual number under this was equated to becomes the main base. Then the actual power is the exact letter or number that we are going to equate to. Having done that, then it means we have converted successfully an exponential expression into a logarithmic expression, such that if we are told to come up with an exponential expression from this logarithmic expression, we will firstly start with the minor base, which we are going to write to. Then we will go to the actual letter or number that is equated and place it in form of a power. Then afterwards, we are going to equate to the many base. So this is how we're supposed to understand. So let's begin. So here are some of the questions. A. Express the following exponential equations in logarithmic. The first one is 2 to the power x, which is equated to 8. Most importantly, one is becoming a minor base, and the other one is becoming the main base. So we're going to come up with our initial, but let's maintain the actual base to be the minor base. Then our main base will be the number that we've equated to. So we're going to bring 8 here. Then that actual power becomes the actual variable or digit which we are going to equate to. If we express it in logarithmic expression, having done that, then it means this is the final answer. Then Roman numeral 2, we're having that is x to the power 4, which is equal to 81. Most importantly, bring in your abbreviation. Then we are going to maintain this as our minor base. Then the actual number which was equated to in the exponential expression becomes the main base. Then we are going to equate this to its power. Having done that, then it means we've expressed exponential expression to a logarithmic expression. So this is how best we can be able to know how we should successfully try connecting exponents to a log. Then we go to B. So on B, we're trying to solve. So we're saying log 2 then 16, which is equal to x. This time around, we are trying to solve a logarithmic equation, but first and foremost, you're supposed to convert it back to an exponential expression so that in form of indices, it will be very much easier to solve. So we're going to say this being the minor base, it means was the actual base. Then the number or variable equated to was the power. Remember, from a logarithmic to an exponential expression, this main base was the actual number that was equated to. Having done that, then we can solve. Remember, this is a base, this is also a base. We are going to turn the bigger base into a smaller base, where we are going to try saying 2 to the power x, and then we're going to express this in base 2. But remember, we're going to find how many times you can multiply this 2 to result into 16. And we can successively multiply it 4 times. So if we say 2 to the power 4, we're going to get 16. So now that the bases are the same, it means the powers are also the same. So I'm going to say x is equivalent to 4. Most importantly, I firstly converted a logarithmic expression into an exponential expression, where I said the minor base, that means was the actual base when converted to an exponential expression. Then the actual variable or number from a logarithmic expression which was equated to is the power. Then the main base you should equate to when converted or when converting it into an index or exponential expression. Having reached this stage, I said 2 to the power x. Then I also had to reduce 16 into base 2 so as to suit the numbers. But then, in as much as I put 2 here, I must correspond with a power that will make these 2 to be multiplied consecutively to result into 16. Since 2 and 2 are the same, x then equals to 4. That's our answer. Then lastly, we're going to talk about log 125, then 5 equals to x. Vice versa, this time around, we are trying to solve it in the same way. Let's first try to convert that logarithmic expression to an exponential expression. Where we're going to say this minor base is the actual base, then this was the power, and then this was the number that was equated to. Having done that, that means we are going to reduce 125 to a base of 5. Remember, this has already the power of 1 because a number being by itself is always raised to the power 1. So I'm going to say this is 5 to the power 3. Then in brackets, then I'm going to maintain x outside. This is equal to 5 to the power 1. The more reason I've said 5 to the power 3 is because when 5 multiplied 3 times consecutively, it results into 125. This is index of an index, so I'm going to say 5, 3 times x, this is 3x, which is equal to 5 to the power 1. Now that the bases are the same, we can equate the power. So this is going to be 3x on the left equals to, on the right, we're going to take a 1. Since we are trying to look for the value of x, we'll divide everything by 3, divide by 3. 3 and 3 cancels, so x equals to 1 over 3. So that's the answer. Fam, out there, if it's your first time on this channel, kindly hit on the subscribe button, like this video, share this video to alert others and to let the channel grow. I hope you're going to grab a paper and relate it into any possible ways that you can be able to invest in proper practice to result in self-reliance. This has been Mr. Sensor from Sensor Academy School of Tuitions. For now, it's a goodbye.